Figure shows a small block of mass m kept at the left end of a larger block of mass capital M and length L. Okay, so this is larger block and length is given, a small block is kept it. The system can slide on horizontal road. The system is started towards right with initial velocity. Means the whole system is moving with initial velocity v. The friction coefficient between road and the bigger block is mu. Here it is mu, and between the two blocks is mu2. Here it is mu by 2. And the time elapsed before smaller block separates from the bigger block. Okay, so we have to see smaller block will separate from the bigger block. First we have to see how will it separate from the bigger block. So how will it separate? So we can see that if these two objects is sliding rightward, there will be a large friction acting from the ground because of the large coefficient of friction, and these two objects will try to slow down. Okay, and as a result, if this lower object tries to slow down, it will also try to slow down the upper object, but the upper object will experience the lesser amount of friction. Okay, and the upper object will try to move rightward relative to lower one. So both of the object will experience the friction force, but the upper object will experience less force, so it will keep on accelerating forward with respect to lower one. Both the objects will experience friction force, both of them will experience retardation, but the retardation in the larger block will be larger in value, and in the smaller block it will be smaller in value. So that's why the smaller block will keep on moving rightward, and finally when it moves rightward by a distance L relative to lower block, it will separate. So this question is related to friction and the relative motion. So we have to consider the acceleration of both the objects, and we have to see whether which one will move in which direction finally. Okay, so we will write the forces of friction and acceleration for both the objects. Okay, so first we will see if this upper object whole the system is moving rightward. So first we will see what friction force will act. So on this one, the friction will act. Suppose this we call as F1. Okay, F1. So if this F1 is acting on the larger block, then it will try to slow down. So upper block is moving rightward with respect to lower. So on upper block there will be friction F2, and there will be F2 on the lower block. So if you see on the lower block, there is a friction force from the ground F1, and there is a F2 from the upper block. Since upper block is moving rightward with respect to lower one will try to be stopped from the ground. So upper block is still going rightward. So upper block will be dragged by the lower block in backward direction. Okay, F2, and as a result, the lower block will be dragged in forward direction. So if you see the lower block, we have two frictions. One is forward, second is backward. And on upper block, we have only one friction, that is in backward direction. Okay. And since all the things are sliding, we can write the maximum friction value. Okay. So the friction F2 will be how much? The mu times normal. So suppose this is N2. So we can write mu by 2 times N2. So N2 will be small mg. So mu by 2 times small mg. Okay. And on the lower block, this is for upper block, friction is there. Okay, and the friction F2. Now F1, if you write F1, how much F1 it will be? So lower block is mu, and normal here is how much? Normal here is suppose N1. So mu times N1. So mu, and how much will be N1? So N1 will be how much? N1 will be, since it is supporting both the weights, small m plus capital M. So N1 will be a small m plus capital M G. I am directly writing these values because we already know that if you have two objects kept one over other, the normal at the ground will be equal to the weight of both the objects. So it will be N1 will be small m plus capital M into G. So that we can write as small m plus capital M into G. So this is the friction force at the lower surface. Now we will write the decelerations for the two objects. So acceleration for small m. Okay, for a small m, acceleration for a small m. So how much will be acceleration? That will be, if you write just magnitude, so it will be how much? It will be F2 by m, that will be mu by 2g. Okay, and similarly acceleration for capital M. Capital M, it will be F1 minus F2 by capital M. Okay, so F1 is how much? Mu small m plus capital M into g minus mu by 2mg. Okay, divided by capital M. So this is the thing we have to do. So mu into g divided by m, and it will be how much? It will be mu g, and so it will be small m plus capital M minus m by 2. It will be mu g by capital M and m by 2 plus capital M. Okay, so in this way we can write. So this is the acceleration of two blocks, and acceleration of both the blocks is in backward direction. This is backward direction or rightward. This is rightward because friction is in rightward direction. And for lower object also, we can see this is larger in magnitude. The rightward force is larger in magnitude. So this is larger. So this is also rightward. Okay. Now we will see relative motion. So relative acceleration of capital M with respect to m. Okay. Then relative displacement, relative acceleration, we will just write the magnitude. A relative, okay, initial velocity relative, since both are moving with velocity v, initial velocity relative is 0, and S relative. So S relative will be equal to L, because as the object moves distance L, it will separate. S relative is L, initial speed relative is 0, and A relative we have to write, that we will write as AM minus AM, larger one minus smaller one we will do. So mu g by m by 2 plus capital M minus mu g by 2. Okay, so this much we have to do. So if we solve it, we are going to get mu g, and it will be small m by 2 capital M plus 1 minus half. It will be mu g small m by 2 capital M plus half. So this is the thing. This is the acceleration of the objects, relative acceleration. If you have relative acceleration, now we can put the equation in the equation. S relative equal to u relative t plus half relative t square. Okay, so this thing we can write, and if you put these values, we will have S relative is L, this is 0, and that is half, and mu g into t square. Okay, so if we solve it, we will have t equal to 4L, 2 and 2 common, 4L divided by mu g and small m plus capital M plus 1 L by mu g. Okay, under root. So this will be the time. In this time, the upper object will travel a distance equal to L relative to capital M. The small m will travel distance equal to L with respect to capital M. So it will separate after this much time. Okay. So in this way we can solve.